Hello everyone. I welcome you all for this lecture series on microprocessor. In today's lecture, we'll be discussing about 8086 microprocessor. So before entering into the architecture, let us see why these microprocessors are used in our day-to-day life. So as we all know, we are using processors everywhere, in systems, in laptops, in smartwatches, everywhere we are using microprocessors. And so this is a typical example where in telemedicine industry how microprocessors or where it is being used. Here we have the wireless cellular device. The data are being captured. Then it's being given to the server. Then from the server the information is being transferred to the hospital and then to the emergency doctor room. So this is how in all these places, wherever systems are being used, wherever these fax machines are being used, everywhere microprocessors are used. Similarly, in every field, we use microprocessors. We use processors in laptops, in systems, in smartwatches, everywhere commonly we'll be using. So different types of microprocessors are available. A basic microprocessor is 8085, which is an 8-bit processor. In today's lecture series, we'll be discussing about 8086. This 8086 is a 16-bit processor, and this diagram shows the architecture of 8086. If we see the architecture of 8086, it can be classified or categorized into two sections. One is the bus interface unit and the other part is the execution unit. The upper half here is known as the bus interface unit and the lower half is known as the execution unit. The bus interface unit consists of these segment registers, instruction queue, memory interface and a small memory to hold the instructions. Coming to the execution unit, it includes general purpose registers, pointer registers, index registers, operands, flags, arithmetic and logic unit, instruction decoder and the control unit. So let us briefly discuss about these components inside the architecture. So as we know, the instruction decoder is used to decode the instructions whatever been received. It finds what are all the data required, what are all the signals to be produced, and so triggers the control unit to produce the signals as well as collect the data, and it will give it to the arithmetic and logic unit for further processing. So to the instruction decoder, the instructions from the memory will be fetched through the instruction queue. Since instruction queue is there, it is a first in, first out, FIFO register. Since it is there will not be any lack of fetching instructions or multiprocessing will be done since instruction queue is there. And these segment registers are used in order to store the data, or in these part of the segments data or the instructions, or part will be used for stack as well. So parts of memories will be used for different purposes. So that is categorized based on these segment registers. Now coming to this lower half, here we have 4 general purpose registers. A, B, C and D are the general purpose registers. These 4 general purpose registers can be used as either 4 16-bit registers or 8 8-bit registers. Next we have the stack pointer and the base pointer and source index and destination index. these two, base pointer and stack pointer, is used to point the datas, or point the address which has to be executed the next after completion of an interrupt service routine. And these index registers are used to point the index values of the instructions to be executed or the datas. Next comes the flags here. So flag is again a 16-bit register. Here we can see that in all these 16 bits are not used. Out of the 16, only 9 bits are being used. Out of these 9 bits, so here we have the carry flag, the parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, direction flag, and overflow flag. So out of these 9 flags, 3 flags are conditional flags. One is a trap flag, second one is the interrupt flag, and third one is the direction flag. These 3 are conditional flags. That is, based on certain conditions, these flags will be enabled. Other 6 are unconditional flags. So their name itself implies, if there is a carry in the result, carry flag will be set. If the result has even number of ones, parity flag will be set. If the result has 0, after a result of a comparison or anything, then 0 flag will be set. If we get a carry, after adding a nibble, we will be getting auxiliary carry flag will be set. Then if there is a negative sign, sign flag will be set. Overflow, if any overflow occur in the result, then overflow flag will be set. Trap flag is when the processor enters a single step execution. That is, every line will be executed one by one. If that has been taking place, trap flag will be set. Direction flag used to show the directions when string operations are taking place. Then interrupt flag, if any interrupts are there, then interrupt flag will be set. So these are other general purpose registers and stack pointer and index pointer registers, as we have discussed earlier. Now coming to the assessment. Briefly, we have discussed about the architecture of 8086. So can you say how many conditional flag registers are there? And we have seen 4 general purpose registers, A, B, C and D. Out of this, how many 16-bit registers are there? How many are 16 bits? So this is for your thought. And thank you.